Alright, so today we will be reviewing factoring, so that way when we start solving by factoring tomorrow, we're all good to go. So there are a lot of different ways to factor, and it just depends on the type of problem we have. So on this first section it says we're finding a GCF. So if you don't know what that means, that's the greatest common factor. And I like to think of it like this. What's the biggest number or variable that I can divide each term by? So like on number 1, we have 12a cubed plus 10a squared. So what's the largest number that 12 and 10 can both be divided by? Well, they can both be divided by 2. They can't both be divided by 3 or 4 or 5. So it looks like 2 is our largest number. So that's going to be our greatest common factor between the numbers. But then when we're taking out common factors between variables, we have a cubed and a squared. So whenever we're taking out a greatest common factor, it's going to sound weird, but we're going to take the smallest power of it out. So the smallest power between 3 and 2 is 2. So we're going to take out an a squared, and then whatever is left over goes in the parentheses. So what would we need to multiply 2a squared by to give me 12a cubed? Well, we still need a 6, and we still need a power of a. What would we need to multiply 2a squared by to give me 10a squared? We would still need a 5, and we already have that a squared there. If asking what would I need to multiply by to give me blank doesn't work in your brain, that's okay. Take each term and divide it by the common factor. We get 6a. Then take the second term and divide it by the common factor. We get 2a squared, and that gives me just 5. So if you have to have scratch work off to the side to find out what's still left over, then that's perfectly fine. Now on number 2, we have 14 and 7. The biggest number I can divide 14 and 7 by is 7. And then I have these variables, m to the 8th power, n to the 5th, m squared, and n squared. So remember, we're taking out the smallest power between them. So the smallest power here of m is a square, and the smallest power of n is a square as well. So we would need to multiply 7 by 2 to give me 14, and we need 6 more powers of m and 3 more powers of n to get to m to the 8th power and n to the 5th. And then to get from 7 to 7, we need to multiply by 1. And then we need m squared to m squared, we still need a 1. N squared to n squared, still need a 1. So then that is what my problem would look like with the GCF taken out. So if it's asking you to find a GCF and factor it out, then this is what it's asking for as your answer. Now on the next section it says difference of squares, a squared minus b squared. A perfect square is a number that when you take the square root of it, you get a whole number. So if I took the square root of 2, it's not a whole number, it's a point something 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 something. So that is not a perfect square. A perfect square is something like 4, because when I take the square root of it, I get 2. So the rule when we are factoring perfect squares is going to be a plus b, a minus b. So we see off to the side there that it's a squared minus b squared as our original problem. So yes, we would have to take the square root of each. So on each of these, we know their differences of squares because this section tells me so. So what I'm going to do is take the square root of each term. So the square root of 9x squared, square root of 9 is 3, square root of x squared is x, square root of 49 is 7, square root of y squared is y. So when I'm factoring that problem, I would have 3x plus 7y times 3x minus 7y. Then on number 4, we have the same type of problem, but I see 72, and 72 is not a perfect square. So what I notice between these two is that I can take out a 2 first. And that leaves me with 36 c to the 4th power minus 1. Now 36 and 1 are both perfect squares, so that's where I'm getting the perfect square from. So I'm going to take the square root of 36 c to the 4th, and that gives me 6 and c squared. The square root of 1 is 1, so my answer, we can't forget the 2, would be 6c squared plus 1 times 6c squared minus 1. So we're having one with a plus and one with a minus, and we take the square root of both terms. Now on number 5, 7 is not a perfect square. If I take the square root of 7, let's see what it is. It is 2.645751, and so on. And so it doesn't give me a whole number. But I know that I can divide 28 by 7, so I'm going to take out a 7 first. And I'm also going to take out my smallest power of m and my smallest power of n. So I'm taking out that GCF, and I'm left with m to the 4th power minus 4 times n squared. So then from there, I would take the square root of both terms that are inside the parentheses. Square root of m to the 4th power is m squared. Square root of 4n squared is equal to, take the square root of the number, and it's 2. Square root of n squared is n. So we're left with m squared plus 2n times m squared minus 2n. But that's not my answer. I cannot forget to bring out whatever I took out first. So my final answer has to have the GCF back in it. And then the last example, 10w to the 5th power minus 10w. Greatest thing I can take out. It's pretty obvious on this one because it's exactly the same, 10w. If I take out 10w from 10w to the 5th, let's do some scratch work here. The 10s will cancel. And then I have w to the 5th power over w. I know those powers will subtract, so I have w to the 4th. 10w divided by itself will be 1. So I'm going to take the square root of both terms. Square root of w to the 4th is w squared. And then square root of 1 is 1. So I'm left with w squared plus 1 times w squared minus 1. And don't forget to put back that GCF. So that's the easy one, whenever we have the difference of squares. Also remember, there's only a difference of squares, there is not a sum of squares. Now on cubes, there are perfect cubes that have sum of cubes and difference of cubes, so we do have to be careful with those two because they have two different rules, but they are relatively similar. So whenever we have the sum of cubes, we have a cubed plus b cubed. We're going to take a plus b, a squared minus ab plus b squared. So we're going to keep the sign the same, change it, always a plus. So in this one, we have to take the cube root to get that a value. So we're going to take the cube root of x cubed, which just like the square root of x squared being x, the cube root of x cubed is just x. And then we'll take the cube root of 27 as well, and that is 3. So we have x plus 3 times x squared. We square that first term, squish them together and multiply with the opposite sign, always plus the last term squared. And we'll do the same thing on number 8. I'm going to take the cube root of both terms. Just so y'all know, I did check in my head if they had any common factors between them. I saw that one had a number, one didn't, and that one was an m and one was an n, so just be aware of that. So I want to find the cube root of 216, and it's 6. So that's 6n, and this top one is just m. So here we have m plus 6n, m squared minus, we're going to squish them together so the coefficient is 6, mn, and then square the last term, square the number, square the variable. Number 9, we have the same type of problem. 4, however, is not a perfect cube, it is a perfect square. So I'm going to divide by 4, I'm going to take out that GCF. 500 divided by 4 is, I want to say 250. 125. Oh, because, wow, okay. Just ignore me. 125a cubed plus 1 is what we're left over with. We'll take the cube root of both terms. Cube root of 125 is 5, and then we have a, and the cube root of 1 is 1. So we are left with 5a plus 1, square the number, square the variable, opposite sign, squish them together and multiply, still 5a, and then square the last term, still 5a. Remember though, we took out a 4 in the beginning, so we cannot forget to put that 4 back. And number 10, same deal. We need to take out a GCF if we can. Let's see, 375. So we'll divide both terms by 3, and then the smallest powers between them of the variables, so c and d. We're left with 8c cubed plus 125d cubed. We'll take the cube root of each of the terms on the inside of those parentheses. And then we have 2c and 5d. So my final answer, 2c plus 5d, square the first, 4c squared, squish them together and multiply, oops, opposite sign, minus 10cd, always plus, square the last term. But remember that we took out a 3CD in the beginning, so it still goes in the front there. And that's my final answer. So the cubes are a little bit more complicated than the squares. Remember that we don't have a sum of squares, only a sum of cubes, and then we have a difference for both. So for the difference of cubes, the rule is about the same. Same sign, opposite sign, always plus. So we'll do the same thing on each of these examples. We're going to take the cube root of both terms. Cube root of x cubed is x, cube root of 1 is 1. So we've got x minus 1, x squared, plus x plus 1. So I'm just following that formula that I wrote above there. Now number 12, we have 216k cubed minus 125. I know that 216 and 125 are both perfect cubes because I used them in the problems above. So we'll just jump straight into working the problem instead of looking for a common factor. We found that the cube root of 216 was 6, and then the cube root of k cubed is k. And the cube root of 125 is 5. So we have 6k, same sign, minus 5. Square 6k, so we have 36k squared. Squish them together and multiply. Opposite sign, plus 30k. And then plus the last term squared, so plus 25. Then on number 13, same deal, but 4 I already said is not a cube. So instead of just jumping straight into it, we're going to take out a 4. 4 divided by 4 is 1. 32 divided by 4 is 8. So we'll take the cube root of each. Cube root of 8 is 2. Cube root of h cubed is h. So we have 1, same sign, minus 2h. Square the first term, still 1. Opposite sign, squish them together, multiply, still 2h. And then the last term squared, 4h squared. We did take out a 4 in the beginning, so we make sure that we put that back before we box our answer. And then on number 14, we have 2x cubed minus 54y cubed. 2 is not a perfect cube, so we need to take out a 2. We cannot take out any variables because they are different. So we're just taking out a 2. We have x cubed minus 27y cubed. We'll take the cube root of each. Cube root of 27 is 3, and the cube root of y cubed is y. So we have x minus 3y, x squared plus 3xy plus 9y squared, and we took out a 2 in the beginning. So I'm still just following that rule, squaring the first and last terms, and then squishing them together to make that middle term. So then on the next page, factoring trinomials. This is just a little bit different from what we were doing before. To avoid this video being an hour long, I'm only going to do a couple of these just because this is a review of factoring. So if you do need help on factoring, We are more than happy to help you with any of that in our tutorial times, but the focus is not necessarily on factoring itself, but how to solve using factoring. So again, this is just a review. We have our previous videos on factoring, and so I am only going to do a couple of these with the trinomials and the 4-term polynomials. So on number 15, we have n to the 4th power plus 2n squared minus 24. And this looks like it would be extremely confusing just because we're used to seeing something like n squared plus 2n minus 24. And so if that is what's throwing you off, then you could say, well, let u equal n squared. Then I have u squared plus 2u minus 24. And that looks something more like what we're used to factoring. So then when we are factoring trinomials that don't have a coefficient in the front, we just find two numbers that multiply to the last term but add to the middle. So I need two numbers that multiply to a negative 24 but add to 2. So two numbers that would do that are negative 4 and positive 6. So my factors are u minus 4 and u plus 6. But remember, u is n squared. So this is n squared minus 4 and n squared plus 6. But this is a perfect square. So since we have the difference of perfect squares, then I will separate that and say that this is n plus 2, n minus 2, based on what we did on that first page, and then n squared plus 6. Then I'll do one with a GCF in the front, so not a GCF, I'm sorry, with a coefficient other than 1 in the front. So this again is x to the 4th and x squared, so I'm going to let u equal x squared. So then this problem becomes 3 u squared plus 14 u minus 5. Now this looks like a problem I can solve. We're going to use slide and divide, so I'm going to take this 3, multiply it by negative 5, and so I get u squared plus 14u minus 15. I need two numbers that multiply to give me negative 15, but add to give me 14. And that could be negative 1 and positive 15. Remember, we multiplied by 3, so I need to divide that back out. So this gives me, this gives me 3u minus 1. And this over here divides to 5, so it gives me u plus 5. But remember, u is x squared, so we have 3x squared minus 1 and x squared plus 5. Now, for 4 terms, we factor by grouping, and for some reason, people tend to not like factoring by grouping, and I love factoring by grouping, and it is something that you will use in the future if you take pre-cal or anything like that. So factoring by grouping is very useful. I personally use it instead of slide and divide, but when we have 4 terms, we have to use grouping. So the first step is to group the first 2 terms together with, the first 2 terms together and the last 2 terms together. So I like to draw a line in between them just so I can see where that split is, and then you'll factor out the GCF for each group. X squared for the front leaves me with an x and a 1. And then for the second group, we're going to take out a negative 4. That leaves me with an x and a 1. We see that these are the same, and they have to be with factoring by grouping, which I like as a checkpoint, so we know, yes, we are doing this the correct way. We'll factor out the common binomial, which was x plus 1, and then whatever you're left over with becomes one factor, so x squared minus 4, which we would have to factor further if it said factor completely. So we're going to do 2 of these. On 21, we have 4 terms. So what we're going to do is split it down the middle. I'm going to take out the smallest power of x between x cubed and x squared, which is x squared. Then I'm going to put back whatever I would still need. So I'd still need another x and then negative 1. Then between 9x and 9, the common factor is 9. And I would still need to multiply by an x to get 9x and a negative 1 to get negative 9. I see the common factor here, which means I'm on the right track. So we have x squared plus 9. It's a positive 9 that we took out, and then the common factor gets written once. We would be tempted to factor further x squared plus 9, because 9 is a perfect square, but we can't because that's the sum of perfect squares. And remember, we only take the difference of perfect squares, so just be aware of that. Then we're going to do 23 as well. We split the problem down the middle, we factor by grouping. So the common number between 4 and 5 is just 1. Then between v cubed and v squared, I'm going to take the smallest power out. I would still need to multiply by a 4. And another power of v to get back to 4v cubed. And then to get to negative 5v squared, I still need to multiply by negative 5. Now on the other side, whenever the first term is negative, take out that negative. So between 16 and 20, the common factor is a 4. And they don't have both variables, so we'll only take out a number. Then to get from negative 4 to negative 16v, I would need to multiply by a 4 and a v. To get from negative 4 to positive 20, I would need to multiply by a negative 5. And I see that these are the same. So I did that correctly. I'm going to take the 2 on the outsides, squish them together, make one factor. And the common factor only gets written once. So then v squared minus 4 is a difference of squares, so I can factor that further. I'll take the square root of both, make one positive and one negative. And we get 4v minus 5 on the end still. And that's my final answer. So I do apologize for this video being so long, but I do think it is important for us to remember how to factor before we move on. So at the top there, you need to write in your rules. And then on number 4, how can you tell if you've completely factored? Well, if you can't factor anymore. So on these, what I want you to do is pick either evens or odds. So for 5 and on, pick evens or odds, but you have to stick with either one. So if you choose to do number 5, then you have to do all the odds. If you choose to do number 6, you have to do all the evens, but you can't flip-flop back and forth and say, well, I'm going to do this one and this one and this one and this one. You have to pick either evens or odds. So either you're doing the left side or the right side, but you're not going to do both. You do have to do 1 through 4, just because that's writing in your rules, and just so you have them all in one place. So make sure that you turn this in on Canvas, and then I will see you guys tomorrow for solving.